Here's problem set number 15, page 159, question number 5. World-class horseshoe pitchers are very active. For example, Alan Francis has won at least 14 world championships, averages over 80% wins. The men's horseshoe pitching court has no stakes, 30 feet apart. The stakes stand 18 inches out of the ground. Alan pitches a horseshoe at 45 feet per second, at an angle of 14 degrees to the ground. He releases the horseshoe at about 3 feet above ground and 2 feet in front of the stake at one end. The perimetric equations modeling the throw, and B holds the horseshoe in the air. I go and to my calculator and type in 40 t cosine 14 degrees. Now from our previous work, 45 times t is the rate at which it's traveling. The angle of release is 14 degrees plus the initial distance in front of the horseshoe, which is 2 feet. Vertically, we have 45 times t again, with 8 times time, times the sine of the angle of release, minus the pull of gravity, so minus 16t squared, plus the initial height. I'm just going to drop this right over here. So there's our equations. Now, I'm also going to take a look at the graph. So I'm going to set up my window. I'm going to assume from playing little horseshoes with my grandpa that t can go from about 0 to 1 second. Maybe it's in there a little bit longer than that, but not much. I'm going to start 5 feet behind the stake and go a few feet, 10 feet past their stakes, since they're about 40 feet apart. I'm going to count by fives. The y, or the height, I'm going to go -2 to 10. -2 allows me to get that axis, the horizontal axis, up at the bottom of my viewing screen. And so here is what the graph looks like. Question B, how long is the thrown horseshoe in the air? Well, if I trace this, just get a ballpark estimate, I'm looking for when this height is about 0, so when y is 0. So it looks like it's about, 40, x is 31 feet, so about 40 feet horizontally, and time is about 9/10 of a second. But I think we can find a more accurate value. So that part B, how long is the horseshoe in the air? That means we're looking for t when the height is 0. So take this y sub t, 45t sine of 14, and 16t squared plus 3. Set that equal to 0. We want to find t when the height will be output as 0. Clean this up a little bit, and I think it's going to look familiar to you and what you should be doing. If I take and clean it up a little bit, there we go, I got two of the same equation. I end up with a -16t squared plus 10.886t plus 3. Now use your quadratic formula to solve for this. And if you use your quadratic formula, t turns out to be a -0.21 seconds. And t turns out to be 0.89 seconds. We saw from the picture up here, this is about round tenths. So your answer to the equation, or to the question, how long will the horseshoe be in the air, is 0.89 or 89 hundredths of a second. Now finishing this up, part C for number 5. How close to 40 feet is the horizontal component when the horseshoe hits the ground? I'll take x equals 45t. This is your horizontal component. But 89 hundredths of a second, and for t, let's calculate. According to our picture on the calculator, the horizontal distance is about 41 feet. So 89 hundredths of a second. horseshoe has traveled 40.9 feet or 40 9/10 feet. So how close to the 40 feet is the horizontal component when the horseshoe hits the ground? Well, it is past the stake, which means if it was on line, there's a good chance it would be a ringer. Part D, Allen releases a horseshoe at 13 degrees or 15 instead of 14. What happens to the length of his pitch? Will his pitch be a ringer? If I take a 13-degree angle, now I have 13 degrees in here, so I have 45t cosine 13 plus 2, 45t sine of 13 minus 16t squared plus 3. I want to solve for this vertical component. When is the height now equal to 0? Solving, t comes out to be two solutions. T is a negative 0.22, which doesn't make sense, or t comes out to be 85 hundredths of a second. So now I take that 85 hundredths of a second. So I get back into this equation. And for t, 5, and x comes out to be about 39.27 feet. So if he throws it at a 13-degree angle without changing the velocity 45, it's going to be another for 85 hundredths of a second, but it's going to come up about 3/4 of a foot short. I believe the same fit, so maybe a ringer slides in there. Hopefully this will help you with the next few problems. Finish up the part D here, figuring out what happens if it's a 15 degree